In continuation with our lecture for the shear force, previously we have already discussed something about the drawing of the shear force for a point load and point loads, whether it is within the simply supported or the overhang. Now this time we are coming across a uniformly distributed load. How to draw and how to calculate the shear force at any point because of the uniformly distributed load, for partly or wholly depends upon the matter which has been given to you. Here now, this is a simply supported span beam with a span AB which is given, that is 4 meter and 2 meter, total 6 meter, with a uniformly distributed load of 20 kN per meter from A up to 4 meter. We have already calculated the reaction. That part has already been covered in my previous lecture. Now, if we start finding out the shear force here, at every meter, first of all we will start with finding out the shear magnitude of a shear force. I will start from A. The reaction is 53.33. If I just go 1 meter from here, the UDL is 20 kilonewton per meter. The total upward force is 53.33. Total downward force is 53.33 minus 20 into 1. For 2 meter it is 53.33 minus 2 into 20. So on and so forth up to 4 meter. And you can find this goes on changing. So instead of the previous, it was just straightway between the two loads. It is varying right from one point to the other till it reaches to its last part of the UDL. Just like this. So it is varying right from A up to C. Just see, for the sake of calculation, shear force at A is 53.33. Shear force at 1 meter from here is 53.33 minus 20 into 1, that is 33. Then it is become 13. Then it becomes minus 6.66, because at every time it is changing by 20 meter. And finally when it reaches to C, that is over here, 53.33 minus 4 into 20 minus 26.66. And there is no load, constant load between the C and B, so it will remain constant, that is just equal to B. So we have to see that under any circumstances, when UDL is there, there will be slope, and where is the point load, it will be direct loading over here. Similarly, you will find over here also. These are the loads. UDL is given from here to here, from here to here. Slope is there, means UDL is there. Or UDL is there, slope is always there. You can straightway calculate and see the values and see the shear force diagram also. Similarly over here also, with one overhang which is given over here. Now once the value is given, you have to start from A as usual, go up to C, then go up to D, then cover up to this B, and lastly reach up to E. Again it is sloping because there is UDLA. It is sloping because it is uniform. Now you will have to find out this point. You will have to find out this point where the shear force changes in from positive to negative. Now you know the distance between the two is given as 4 meters. Suppose this is x, then you will have to find out this 4 minus x. This ordinate is known, this ordinate is used. Using similar triangle concept, you can straightway calculate this point. This is the point where the shear force changes the sign from positive to negative, is a point where you will find the maximum bending moment. When we will go through the bending moment, we will come across that point. That's why it is essential to know that point where the shear force changes the sign from positive to negative. Now at all the time it is not necessary to go for 1 meter, 1 meter, 1 meter. Start right from here to here. Right from here to, you can straightway go from C to D directly. First of all up to this, and then this load is there. Then this load will be there. Accordingly, we can just proceed ahead and find out the shear force diagram from the uniformly distributed load from A to E. One important thing I just again wanted to emphasize, that find out that point where the shear force changes the sign from positive to negative, because this is most important. This is most important to find out the magnitude or the point where the shear force changes the sign from positive to negative or from negative to positive, depending upon the overhang is on the left side or overhang on the right side, or the load is according to the conditions of the load. You can solve the problem and you can get the answer accordingly. Thank you very much.